Welcome back to Pine Hollow Auto Diagnostics. We're back on the construction site. Yep, it's the same Genie. This time, crank, no start. Every time I come out here, it's a different problem. So it makes it interesting. Remember, we replaced the starter, I did the oil change, I fixed the fuel line about a month ago. It rubbed through and it was leaking. It's run fine until this weekend. The guy says, "Hey, Ivan, my Genie doesn't start. Come help me." So here we are. This thing is parked up against the building, which makes it a pain to open the engine cover. The battery was pretty drained from them, trying to start it. So I have it hooked up to the XL7. We're just running it, charging it a little bit. So to get under here, it's possible. What are we checking for on a crank? No start, spark, and fuel. So first check, let's check for spark. I don't know how I'm going to do this. The start switch is on the other side. The ignition coil's on this side. So we could put a spark tester in it and hook up the Veriscope and just record to see if the coil is being controlled. Or we can hook up a remote start switch, or whatever is easier. So let me hook that up, we'll check for spark, we'll go from there. How about this camera shot? Here's a spark tester. I have it right in the ignition coil, grounded out. Let's see if the spark jumps the gap. I'm going to review the camera footage after I crank this thing. Ugh. You guys see anything? Alright, so we didn't have a spark. It didn't look like it in the camera. Next step, what controls this thing? I say go for the crank sensor. It should be pretty simple setup. There's no OBD2, camshaft, crankshaft stuff. I don't think. We could pull up a wiring diagram, find out where the sensor lives. I don't think I can use all data here. Pull up an actual factory manual for the Genie. Let me do a little research and see what our next easiest step is. Alrighty, doing a little research. Here's a factory manual. I apologize for the glare. It's as bright as my screen can get. So it's telling me how I can pull trouble codes out of this engine computer. Pull out the ground control's red emergency button. Hold the run test toggle switch to the test position and turn the key switch to the ground controls position. Check engine light should turn on, check engine light should begin to blink. Okay, and then there's a chart with the trouble codes. Well, I turned the key to on, that check engine light is not lighting. That's a problem. Our computer could potentially be offline. Okay, so there's a check engine light, and then this is the only toggle switch I see, so that's the only one that I can think of that I can find. So, keys off, hold this toggle switch on. That check engine light is completely dead. Crank no start. Good thing is we actually have pretty good access to the engine computer over here. There it is. Got all the wires we want to test. So right now the key is find a good wiring diagram and start from from the basics, powers and grounds, and we can see the crank signal out here, we can see the coil controls, injectors, etc. So this will be the perfect testing point for our diagnostics. So in cases like this, you have to make a game plan. Just sit down with your computer and your notebook and write down your game plan, because otherwise you'll start running around in circles and waste a lot of time. So we have the schematic pulled up of the engine computer. There's the entire thing. We've got injectors, there's the crankshaft position sensor, ignition coil. We're doing all our checks at the computer. It's nice that they have the connectors labeled A through Y, and the pins are 1, 2, 3. So each pin here corresponds to connector location. Beautiful. So I went through this whole list and picked out exactly what we want to check. And I wrote it down in my notebook. Here's how I like to do it. So at the PCM, here are the powers. V power, keep alive power, and the 5-volt reference. Wiring color and pin number. Then we have 4 grounds. We have our crankshaft position sensor. It's a typical Ford unit, VRS type, so plus and minus. 1 injector and 1 ignition coil. So we have wiring colors and pin out locations. Now we can get out our scope or our test light, go to the Genie, and do our checks. The first wire that I found, and this connector, that's the first one, the brown and white, that's our 5-volt reference. Keys on, we got nothing, so we're on the right track. Already, first check we did, V reference, brown and white, and this is result 0 volts. This is key on, engine off. Okay? Don't like that. Let's check the 2 powers, K1 and F2. Let's find those pins. Well, here's one variable. The connector layout, you see there's 5 pins, a bolt, and 5 pins. That's not what these guys look like. We have 12 pins across. That's not good, and there's no bolt holding these things in there on a clip. Might have to verify our wiring diagram, because if we can't trust that, then all our checks won't be conclusive. Alright, getting a little frustrated because the diagram doesn't match up, so we have to be very careful. Some of the colors do match up, some of them don't. Here's where we are. I found the relay box right near the engine control module. So these 3 relays have to deal with the engine controls, not the ones on the control panel. Very key. So they are these 3 guys. There's a starter cutoff, so even if you unplug it, the starter will work. The only way the starter doesn't work is if the relay is energized by the computer, which prevents, has a delay basically to start the engine. Not really worried about that. Fuel pump and power. So the fuel pump relay, you can see the load side comes from, well, we can verify, since the colors don't match up, we don't even know which one the fuel pump relay is. But what we can do is get our test light out and do a quick check on these pins. See if we have power anywhere here at all. Alright, doing a couple quick checks. Pretend you don't know which relay is which. We just have a test light going to ground. Start poking. Alright, we do have a light on there. That's the main red wire that goes to this relay. Let's keep going. Second relay, we have a power right there. Third relay, different wiring colors, it's not red, and that's the one that will energize when the starter is engaged. So we can show that. I don't know what the best way. The sun's going to be a little annoying here, but we can at least set you guys up, and you'll see the test light when I crank this thing. Alright, here we go. Key on, and maybe I can see my test light. Oh, I can't. Crank it. Nope. Please do one thing we do know. So this guy, I believe, is the fuel pump relay. So it's usually safe to jump through a fuse, constant power to the load. You're just being the switch, even though the computer isn't commanding the pump on. So when we do that, Yes, the fuel pump runs. This is the fuel pump relay. The green and orange, even though it doesn't match up on the diagram, look on the control or the load side, it says pink and black. So the diagram we cannot trust, but we can only use it as a guide. So fuel pump relay, starter relay, power relay. That's the one that's really our concern. So what, on the power relay we had a good feed. So that means this wire coming from right here, it says V power. I think that's just constant power. The fuel pump relay, we saw the test light lit up on the load side on the feed, and so did the power relay. So this, on the load side, that pin is good. If that relay clicks, where does that power go? Let's see. It goes on this red wire, and that goes to V power on our computer. So that relay must turn on to power up the computer, and also everything else. Throttle position sensor, the injectors are on there. So that's a key relay. If that doesn't work, nothing will work. What makes the power relay turn on? Let's look at the control side. Control side, pins 85 and 86. One of those wires is tied to keeps coming over here, keep alive power, red and light green. Okay, that should be on all the time. Keep alive, right? The control side, it shows here, goes right to here, which is tied into all the grounds, all the computer grounds, and it says here battery ground. Okay, so what can we do? Even if we jump 30 to 87 and power up the injectors and the computer, without the keep alive memory, this thing might still not run. And also, is that safe to do? Well, pretend that you don't have power there, but you got, V power. Would that cook something in the computer? Maybe. I don't think so. I think we need to try to restore the, are we missing anything? This power relay, let's do a quick check. So test light to ground. On the load side, we have a light here, and on the output of the load side, when we crank the engine over, here you guys see the test light there. Alright, so key on, crank the engine over, no light. So either A, the relay is bad, or B, we don't have a control here. And right now, we know, test light's good, we do not have power on this red and green wire, which is the keep alive. It also powers the control side of the fuel pump relay. Also no power there. So, right now, we know, at least, we're missing the keep alive power, which is the feed to the control side of the power relay and the fuel pump relay. Okay. So if we're missing keep alive power there, a lot of stuff might not work. And we can try, since it says the other side of the wire, see it says right here, it's a red and yellow. However, on the diagram, it's just a black and white, which is a ground. So this might not be a constant ground. So we might be missing a power, and we don't know what this other wire does. So what I want to do right now is see, A, is that red and green wire, is it shorted to ground? Did it blow a fuse somewhere? That's problem number one. Number two, we can do a bypass check. If it doesn't draw a lot of current, safe check, we can actually restore that power and see if the damn thing runs. Let's try that. Alright, so my test light now is being fed by battery power. If it finds the ground, it'll light up brightly. Let's touch that red and green wire. It lights up dimly. Same with this guy. So that's definitely the common wire. And if it's powered up, the test light should not light. So again, missing the keep alive power. Alright, so, and it's not short at the ground since the test light is dim. It's only 150 milliamps here. So what I'm going to do is jump here to there, restore the keep alive power, and see if the thing cranks up. Okay, here we go. Jump red to red and green. 10 amp fuse. I heard some relays click. Nothing, no sparks yet. Again, test light to battery ground, just to make sure. We got power there. We got power there. Let's try this one. We got power there. So we restored the keep alive power. Let's see what happens when I actually turn the key. Key on. Let's crank it. Still nothing. Okay. Alright, so I don't know if we're getting anywhere. Let's see if the power relay now clicks on. So if I ground this pin, we should get power to the computer. Right? And this thing should fire up. I mean, first check we could do is, A, is the power relay getting turned on when we're cranking? Again, test light. No, it is not. So, if we just turn on that power relay with our test light, it clicked. Let's make sure we have a solid connection here. Alright, power relay's on. Let's see if it fires up. Dang, still nothing. I thought it would actually fire up. Computer's plugged in, everything's plugged in. This thing is a real pain in my butt. It's a nice Saturday, I should be out mountain biking. This is really bizarre. I'm trying to find if there's continuity between the power relay, load side, boom, and it feeds like an injector. I got to an injector. You guys can see that. Right here, I'm back probing it on the red wire. It should be coming right from the power relay, which is right here. Through a fuse. We get 0 or infinity, no continuity. That's not good. Let's try test our meter. 0 ohms. Next step is it's going to the fuse from here over to here. This is a really frustrating case study. And we have 0.6, that's good. Other side of the fuse. Again, 0.6. And then from here, this wire should go, again, not having a reliable diagram is really, really painful, but it should feed all these injectors. It's not. What gives? Alright, so continuity check now from the red wire coming from the injector to somewhere over here. Here's our test lead. What I found was this pin right here on the PCM is the same wire that goes to the injector. So it's a red wire. This one right here. Again, obviously the diagram's not accurate. Now, this is the PCM, that's the injector. The feed has to be coming from somewhere right here. You know, from the power relay, it has to be. And if we touch that pin on the power relay, look at our meter, we got infinity. So, is there a break in the wire somewhere between here and right here? There's a splice, because the wire goes through all the way to the injector, and it can't go anywhere else. It has to come from right here. Let's explore a little further. Alright, well, it's been honestly more than 3 hours. The Genie is about to run. It hasn't run yet. Here's what I've done. The biggest problem is the wiring diagram is not accurate. Therefore, you have to spend a lot of time tracing wires, doing continuity checks, seeing what you're missing. You don't know which wires are the powers or the grounds. It's really frustrating. One of the most frustrating things as a diagnostician is not having the right wiring diagram. Just looking at this connector, I'm like, you know what? The red wires, those are usually power wires. Let's try, first with a test light and then with a fused jumper to give one of these red wires power. We know that the middle one goes to the injectors, V power, and that's a feed to the PCM. However, the other two were at 0 volts, and test light from battery positive to those wires did not light them. It did raise the voltage. With those wires energized, you turn the starter over and the fuel pump came on and the check engine light came on. I'm like, well, that is a great change in direction. So we are missing a power feed to the PCM. So okay, let's leave that wire energized. I cranked it over, it like sputtered, wanted to start, but then didn't want to start anymore. Where do you go from here? Well, I grabbed one of the injector control wires, since those are, we're fairly certain that, at least this white one's like injector number 1. Hooked up the scope to it. I have it charging over here since this is taking for freaking ever. We got an injector pulse. Alright, so that's good news. Injector's coming on. Before, the injector had no power. So that one of those red wires is almost like a wake up to the computer, and then the other one gets energized. So it's just really kind of bizarre. I don't know why it's missing that power feed, but I just want to make the thing run right now. We have injector pulse, it coughed a little bit and then stopped running. Check for spark, we do have spark now. What the heck? We have fuel, spark, what else does it need? I did a fuel pressure test. No fuel pressure. I mean, the relay's being energized, I checked that. The fuel pressure gauge reads 0. Then I unhooked the fuel pump right down there. Energize the fuel pump, nothing. Nothing. What the heck? It's like dripping out a little bit. Fuel pump does not come on, but it did a little while ago. What gives? Well, I tugged on the wires. They go to the fuel pump, and apparently they've been bypassed. So here's our it looks like a pink and black, but if you look inside the harness, it's actually orange and black. Right there. So color or wires can change color and really throw you off. And then a brown. So these two go to the freaking fuel pump. And one of them got disconnected because I was pulling on the harness when doing those checks. So here's the crappy, someone made this and it worked for a while. This end goes to the harness, this end goes to the fuel pump. One of the connectors is basically broken off. That doesn't help either. So we're gonna do a bypass test. I have some AES wires rigged up, male, female on this end, and then 2 males on the other end. We're gonna connect the fuel pump to the original harness, do the bypass power on the computer, and see if this thing finally fires up. All right, got the AES wave bypass wires rigged up. Man, I gotta take a breather here. So again, let's hook up our computer power. And I just hook it up to the main power here, actually on the fuel pump relay. Okay, so now let's see if the fuel pressure actually builds. So key on. There we go. Now we hear it. I like it. What's the fuel pressure now? Oh, I didn't register. Well, I heard the pump kick on. I don't know. Freaking, let's just fire this thing up. Alright, here we go. Let me pull this off. Boom. It needs that computer power. Abso-freaking-lutely. So 2 problems. 1, fuel pump. Well, I don't know if it was disconnected. I guess when I pulled the harness, I disconnected it. So that problem was built in by the diagnostician. But when you're working in these conditions, what the heck? But it's missing this power feed. So we're not done. We proved that it runs. We proved the problem. Where does it come from? I don't freaking know. I don't have a good wiring diagram. But does it run on 10 psi? I don't know what the fuel pressure is. Should be. What do we have to do to raise this thing? You have to hold something and then raise something, but oh man. Boom. Alrighty. So I don't know where to leave this. I mean, you can't leave it like this. We could run a keyed power to here. Maybe from the from that, what do you call it? Keep alive power. Like, that could work. We could try that. Actually, right here. So we'll just grab a green and yellow, or I'm sorry, red and green. See if that bypass would actually work, and then we can just make a jumper. It works. Thanks a lot for watching. See you guys next time. Bye-bye. So a little bonus footage. What's the repair strategy here? Well, these two power wires, these two red wires, the lower two, are the same wire, since the resistance between them is negligible, about 1 ohm. That's the same feed, as just comes into the computer in two places. The third one, the higher one, comes from this, well, it goes to the injectors, and it comes from the power relay. We can prove that by, let's see, we'll go from here to, get out of here, come on. The power relay right here. That's gonna make a liar out of me. Oh, we know it goes to the injectors, right? And we know it goes to the computer. But remember, we were kind of on the wrong track where it comes to this relay box. So I salvaged the old fuel pump harness, just crimped down a new female spade connector. Let's see if this thing fires up with the bypass. Check engine light is fuel pump should work. Ah, crap. What do we do now? What's the fuel pressure? Oh, man. This thing's driving me up the wall. 50 pounds. Okay. Well, what happened to our bypass here? It's the same damn wire. It's coming from the red and green. Now we got fuel pressure. So key on, nothing, and then when you hit the start, that voltage should come up and then it'll time out. The thing should fire up. Unbelievable. Is the fuel pump running? I don't hear it. Crap. Oh. What do we do now? Oh, we got like 55 pounds. Let's see, let's drain that. Yeah, we definitely have fuel. Now we're down to 10. Unbelievable. How's your fuel pressure doing? So our pump's not running. It's all connected over there. I see you, you're all connected. What's wrong? I don't get this. Jump the fuel pump. Turns on. Fuel pressure is like nothing. Is it spinning backwards now? So what we're gonna do is run a jumper from this red and green, the keep alive memory that actually turns on with the key, with that relay, right to this red computer power. The way I do that is very easy. Take your strippers, set it, to the appropriate gauge, go right over the wire and tug, and the insulation will come apart just enough so you can solder a wire, splice it in. We don't want to cut the wire, we just want to solder it to the copper right there, and then we'll wrap it up nicely. Obviously you can't put heat shrink on this type of connection, but in here, pretty nice and dry and out of the elements, so not too worried about it. It's going to touch up some solder there and we'll be good to go. Alright, moment of truth. The magic red wire installed. Let's see what happens. If this thing doesn't work, I'm gonna cry. Yes! That's it. Honestly, I've been here 6 hours. Diagnostics, repair, lack of information. So enjoy the video, and sometimes you just gotta do what you gotta do. The Genie runs, bottom line, and see you guys next time. Bye bye.